Hello, future data scientist. Welcome back to week 2 of our 12-week data science series. In today's episode, I'm going to do a deep dive into the heart of statistics. Now, as I have mentioned in my previous videos or even on my YouTube shorts or Instagram reels, that math is an extremely important part of data science. In fact, statistics forms the foundation of data science. So this is a very important video. Consider it like a foundational video in your journey of data science. Having said that, statistics is extremely simple to understand and it's nothing to be overwhelmed by. What we are going to cover today are basic concepts that will help you understand how you have to treat your data and when. So we will cover concepts like mean, median, mode, central tendencies, and how and when you can use these central tendencies, how outliers have different impact on different central tendencies. We'll do standard deviation, we'll do variance, and at the end of it all, I'll walk you through a bell curve, that's normal distribution, and how to read it, how to interpret it, and how you can use it in your data sets at an industry level. So if you are extremely new to all of this and words like variance, standard deviation, normal distribution, or bell curve sound very heavy for you, don't worry, we are going to do a deep dive and I'll try my level best to simplify those concepts for you. If you're a seasoned data scientist and you're just here for a crash course or to just refresh your memory, again, you're also at the perfect location because I will cover all of the important basics and we'll be very quick with it. Okay? So the first item is how to calculate mean. Now, mean is one of the most basic forms of any central tendency. In day to day life, you might have heard the term average. Average is nothing but mean. But in data science terms or machine learning or AI terms, we are always going to refer to it as mean. So, how do you calculate your mean? Now, for the given data set, you have these following elements 2, 4, 6, 8, and 10. How do you calculate the mean? Mean is nothing but sum of the elements divided by the number of elements. So you simply add up all the elements in your data set and divide it with the number of the elements in your data set. So how do we get the mean for this particular data set? We add all the elements in the data set 2 plus 4 plus 6 plus 8 plus 10 and we divide it with the number of the elements. How many elements do we have in this data set? 1, 2, 3, 4 and 5. So we divide it by 5. The total of 2, 4, 6, 8 and 10 comes out to be 30. We divide the 30 by 5 and we get value 6. So the mean of this following data set is 6. Again, what is mean? Just the sum of elements divided by the number of elements. Next is median. How do you calculate median? Again, median is another form of central tendencies. There is no high level of mathematical calculation involved for calculating median as well. Median is very simple. It just means middle value in a sorted data set. So now we have been given this data set. We have to sort it. By sorting, I mean you have to arrange it from the lowest element to the highest element in a ascending to descending order. So the sorted data set over here is exactly the same like it was given to us 2, 4, 6, 8 and 10. This is because this was already sorted. We don't have to put in any effort over here. How do we get the median for this data set? It is nothing but the middle value. So 2 cancels out 10, 4 cancels out 8. We end up with 6 as the middle value and that is our median. Now if you notice this data set has how many elements? 1, 2, 3, 4 and 5. 5 is an odd number. For any data set that has odd number of elements, you're always going to have one middle value and your median will be a singular value. It's very easy when you have odd number of values in your data set. But if you have even number of elements in your data set, suppose there was a sixth element here, 11. So our data set would be 2, 4, 6, 8, 10 and 11, which would be 1, 2, 3, 4, 5 and sixth element 11. So how do you get
the median for that data set. Again, you sort the data set from lowest to highest. 2, 4, 6, 8, 10, 11 is already sorted for us. We don't need to take any effort again. We just put it over here and say, okay, this is our sorted data set, 2, 4, 6, 8, 10 and new element 11. Now 2 cancels out new element 11, 4 cancels out 10. You are left with two middle values, 6 and 8. What's your median now? In this case, you take average of the two numbers. What is average? Mean. And how do you calculate the mean? Mean is nothing but sum of elements divided by the number of elements. So if we have two elements over here, 6 and 8 left as middle values, how do we take their median? What's the average? 6 plus 8, 14. 14 divided by 2 is 7. So in that case, our median would be 7. So again, how do you calculate a median? To calculate a median, it's just middle value in a sorted data set. But if you have odd number of elements in your data set, this works perfectly fine. If you have even number of values in a data set, simply take the average of the middle values. Next is how mean and median handle outliers. Basically, when you should use mean and when you should use median, because both give central tendencies. Now, if you see for our example, which we have been using for so long, 2, 4, 6, 8 and 10, the mean was 6 and the median was 6. If you go back to the first slide, you can see here we had calculated the mean, sum of elements by number of elements, and we had got the mean was 6 for 2, 4, 6 and 8, 10. For median 2, 4, 6, 8 and 10, we had got the middle value in a sorted data set as 6 and median was also 6. So our mean was also 6 and our median was also 6 for this particular data set. But if I change the data set a little bit and I introduce an outlier, an extreme value, I change the 10 to 100. Okay, why did I change the 10 to 100? Because my purpose, my aim was to introduce extreme value, was to introduce an outlier, just to see that in case outlier is introduced to the data, how do mean and median behave. Now, how do you calculate the median? You sort that data set from lowest to highest. Again, this is already sorted from lowest to highest. So you simply take the middle element. How many elements does this data set have? 1, 2, 3, 4 and 5, which means it is odd number of elements in this particular data set. So you are going to have one single value as a median. What's going to be the median? The middle value. So 2 cancels out 100, 4 cancels out 8, 6 is your middle value, that becomes the median for this new data set. And the median comes out to be 6. The mean comes out to be 24. So now if you compare for our original data set which has no outliers, the mean was also 6 and the median was also 6. But if I change the 10 to 100 to get an outlier, the median still remains 6. The median has not changed. The central tendency has not changed in spite of introducing an outlier. However, there is a drastic difference in the mean. Mean has gone from 6 to 24. That is, it has changed at least 4 times. So this means median is very robust to outliers and can handle outliers much better than mean. That's why when you have a lot of outliers and you don't want your data to be skewed towards the outliers, you will always use median as a central tendency. Okay, now here I have not shown the calculation of how mean comes out to be 24 for this particular data set. That's a homework assignment for you. Take this data set 2, 4, 6, 8 and 100. Try to find out its average and let me know in the comment section if you do get the mean to be 24. The next is mode. Again, mode is also a central tendency. It's extremely easy to calculate. Again, no sophisticated mathematical calculations are involved over here. Mode means nothing but most frequent element in your data set. How do you get the most frequent element in your data set? You simply have to count the occurrence of the elements in your data set. And the highest occurrence is your mode. So now, I jot down the elements. Which elements? The unique elements in my data set. So I'll traverse through my data set. First element is 2. It is unique. I have not jotted down 2. So I will write down 2 in my unique element list. I move on to the next element. It is again 2, but it's no longer unique. I had already jotted it down. Then I move to 4. 4 is unique. I had never jotted down 4. So I jot down 4 in my unique element list. I move to the next item, next element, 4, again not unique. I already have it in my list. I move to the next item, 6. I just had 2 and 4 in my list. So 6 is unique. I jot it down. So my element list is 2, 4, 6 right now. Next element is again 6, no longer unique. I already jotted it down. Next element again 6, no longer unique. And the next element 8, yes, 8 is unique, so I jotted down. Now I will calculate the frequency of my unique elements. What is frequency? Occurrence. What is occurrence? How many times you can see the particular element in the data set. So first unique element is 2. How many times do you see 2 in this data set? 1 and 2, which means the frequency is 2. So this means element 2 has occurred 2 times in the data set. Next element is 4. How many times do you see 4 in the data set? 1 and 2. So frequency again is 2, which means the element 4 has frequency 2, which means element 4 was seen twice in the data set. It has occurred twice in my data set. Next unique element is 6. How many times do you see 6 in this data set? 1, 2 and 3. So the frequency is 3. What does this mean? Element 6 has frequency 3. Element 6 has occurred 3 times in the data set. It was seen 3 times in my data set. Similarly for 8, it has occurred only once. So the frequency is 1. Now in the frequency list, the highest frequency is 3 and the corresponding element is 6, which means 6 is my mode. Why is 6 my mode? Because mode means most frequent element in the data set, and according to our calculation, 6 was seen thrice. No other element was seen thrice, which means 6 is the mode of this data set. Next is how to calculate the range. In simple terms, range means nothing but span. How do you calculate the span of your data set? So in my data set, I have 5 unique elements, 2, 4, 6, 8 and 10. How do I get the range? Jot down your maximum element, jot down your minimum element. Maximum element means the highest element in your data set. The highest element in my data set here is 100. The lowest element is 2. That's my minimum element. And for range or span, I simply do maximum minus minimum, which is 100 minus 2, which is 98. So for this particular data set, the range or the span is 98. The next is variance and standard deviation. These concepts are extremely crucial. This form the foundation of a lot of machine learning algorithms and computational algorithms. If you do not understand it once, I would highly advise you to go through this slide at least twice or thrice so that your concepts are very, very clear. Okay, don't get overwhelmed with all the information written on the slide. It is extremely easy to understand. So now we have been given a data set. 4, 5, 6, 7 and 8 are the elements of our data set. So what we do is to calculate the variance, step 1 is to calculate the mean. How do you calculate the mean? We have already seen mean means nothing but sum of the elements divided by number of elements. So I add up all the elements in the data set and divided by the number of elements and I get the value 6. So the mean of this particular data set is 6. Next step to calculate the variance is to calculate deviations from the mean. What do you mean by deviations from the mean? Deviations from mean means distance from the mean. What is distance from the mean? Distance from the mean means how far is the element in your data set from the mean. How do you calculate it? Just subtract it. So you subtract the element of the data set from the mean. How do you do it? 4 minus 6. So how far is 4 from 6? Minus 2 points. It's away by minus 2 points. How far is 5 from 6? How far is this element from 6? How far is this element from the mean? What is the distance of 5 from 6? How do you get it? 5 minus 6, which is minus 1. So this gives the distance. And so on you calculate 6 minus 6, 7 minus 6, 8 minus 6 and you get this array. What does this array represent? This represents nothing but distance from the mean. Distance of the elements from the mean. Now in the next step, simply square these. So what do you get over here? Minus 2 square is 4, minus 1 square is 1, 0 square is 0, 1 square is 1, 2 square is 4. And now we calculate the variance. Variance is nothing but sum of square of distances from the mean divided by number of elements. Now read it carefully. Sum of squares of distances from the mean. Do we already have this item, sum of square of distances from the mean? Yes, we have it partly, because if you see here, in this step over here, we have calculated distances from the mean, and in this array we have calculated squares of distances of the mean. So we simply have to add these to say that we have sum of squares of distances from the mean. So we add all of these values, 4 plus 1 plus 0 plus 1 plus 4. What does this give us? This gives us sum of squares of distances from the mean divided by number of elements. How many elements do you have in your data set? 1, 2, 3, 4 and 5. So you divide it by 5 and you get your variance to be 2. What is your standard deviation? Nothing but square root of variance. In this case, what is the standard deviation of this data set? Nothing but square root of its variance. What's the variance for this data set? We have already calculated it. It's nothing but 2. So standard deviation of this data set comes to be square root of 2, that is 1.41. Again, how do you calculate variance and standard deviation? You simply have to calculate variance first and just do a square root to get its standard deviation. To get your variance, you simply have to do three simple steps. First is to get the mean, second is to get the sum of square of distances from the mean, and third is to put all the items in this formula, sum of square of distances from the mean divided by number of elements, and you have your variance. Next is how to calculate your IQR or interquartile range. Now what does this IQR represent? This represents the middle 50 percentile of your data. How do you get it? So you get it by subtracting your Q3 minus Q1, that is your 75th percentile minus your 25th percentile will give you the information about your middle 50 percentile. How do you get it? Simply take the median, which will act as your Q2. How do you get a median? We have already seen it. Median is nothing but middle value in a sorted data set. This data set is already sorted. No need to put our effort into it. What's the middle value? 2 cancels out 14, 4 cancels out 12, 6 cancels out 10. We are left with 8, and 8 is our median. We got a singular value, which means the elements over here are odd. How many elements do we have? 1, 2, 3, 4, 5, 6 and 7. 7 elements, odd elements. So we have one single middle value, that is our Q2. The median comes out to be 8 and our 8 is going to be represented by Q2. Now once you have Q2, split the data set into two parts. Left of your median and right of your median. Left half of your median will be 2, 4 and 6. Right half of your median will be 10, 12 and 14. Now in the left half, again sorted. This is already sorted, so you don't have to sort it. What's the median of the left half? What's the middle value? 4. So your Q1 comes out to be 4. In the right half, again sorted. This is already sorted. No need to sort it. What's the middle value? 12. The median is 12 of right half. That's your Q3. So now you got Q1 to be 4, Q3 to be 12. How do you calculate your IQR? Q3 minus Q1. That's 12 minus 4 and you get your 8. That is how you calculate IQR. That's your interquartile range. The next item is very interesting. This is called as the normal distribution or the bell curve. Over here you can see two items. One is mean and second is standard deviation. So do you see something like a U on the screen that I am pointing to? That is referred to as mu and it stands for mean, and this other sign is called as sigma right beside 3 and this stands for standard deviation. So now let's take a very close look at our bell curve, or also called as normal distribution. This shape shows how most data points in a data set tend to cluster around the average, and as you move, fewer values appear. Imagine you're looking at adult height. The mean or average is 5 feet 7 inches. That will be the center of your curve. But not everyone is exactly 5'7", right? So we measure how spread out the data is using something called as standard deviation or sigma. One standard deviation away from the mean. So mean plus or minus one standard deviation. If you do mean plus one standard deviation, you would go somewhere here. So, and if you do mean minus one standard deviation, you would go somewhere here. So the whole part would be represented by the lightest blue color that you see over here. One standard deviation away from the mean in this data set, that's between 5.4 and 5.10, includes about 68% of people. So if you meet someone at random, there's a 2 in 3 chance their height will fall in this range. Two standard deviations, that's 5.1 to 6.1, that is this darkest blue, not the darkest blue, the middle dark blue, that this one will capture around 95% of people. Only 5% of people will be shorter or taller than this. And finally, third standard deviation, three standard deviations away from the mean would mean from 410 to 64. So that would mean even this darkest blue is captured. So this whole area is captured. That represents 99.7% of people. So anyone outside this range, anyone below 410 or anyone above 64, is considered very very rare, very very unusual. So what does it mean to be one or two standard deviations away from the mean? It means you're slightly above or below average. And that's why the bell curve is so useful. It helps data scientists spot patterns, identify outliers, and build models based on how typical or atypical a value is. Thank you for watching this video. In this episode, we have covered all the mathematical concepts or the statistical concepts that form the basics of data science or machine learning. We covered mean, we covered median for odd number of elements and even number of elements. We covered how to calculate mode, range, variance, standard deviation, even IQR, and how to read a bell curve or a normal distribution with an example. These concepts will be extremely helpful once we start solving machine learning problems. So if you do have the time, I would highly recommend you to solve some examples related to each and every of these concepts. If there is any issue, or if you get stuck somewhere, or if you have a doubt, do let me know in the comment section and I'll definitely get back to you. Do like, share, comment and subscribe. If you do subscribe, do not forget to click on the bell icon. In that way you'll always be notified whenever a new episode comes out. Stay tuned for week 3 of our 12-week data science series. See you soon.